The lesson outcome for this video is I can add and subtract rational expressions with like denominators. Okay, so let's think back to fractions that we've added in the past. Let's say we have a pizza, and the pizza is divided into 8 sections, 8 equal slices. All right, they're not totally equal here, but there we go. Pretty close. Well, what if I said I ate 1 slice out of that pizza, and that pizza has 8 pieces, right? And then let's say I ate more, and I went back and I took 2 more pieces. I took 2 more slices out of 8. So the question is, how much of the pizza have I eaten? I ate 1 slice out of the 8, and then I ate 2 more slices out of the 8, which means I've eaten 3 slices out of the 8 slices of pizza. So I first ate this one, and then I ate another one, and then I ate another one, and then there's the other ones that I didn't eat, but there's 3 out of 8 that I ate. All right. Notice what we did with these fractions. When we're adding fractions, we added the numerators and we got 3, but notice we left the denominator of 8. Because if I would have added the 8s, I would have got 16 here, which meant I ate 3/16 of the pizza. Well, I didn't eat 3/16 of the pizza. That's a pretty small amount. That'd be dividing each of these into 2 pieces and eating 3 of them. So that would have been only 1.5 pieces of pizza. So it's not 3/16. It's 3 out of the 8. So you might remember that when we add or subtract fractions, we need a common denominator. And that's why this is in the lesson title here. We're going to be adding only today with like denominators. Later we'll talk about what happens if we have not common or like denominators. Let's say I said I had 1 piece of the pizza out of 8 pieces, and then I went back and I ate half of the pizza. Okay, notice that those are not common denominators. We would not be able to just add these 2 fractions right now. We would first need to get a LCD, a least common denominator. So more on that kind of situation later. So let's take a look at this example here. 9 over 3m plus negative 12 over 3m. Well, because they have a common denominator, we can simply add the fractions by adding the numerators and leaving the denominator. Now, this is writing it out the long way, and you don't have to do this every time, but I'm going to show you. It's 9 plus negative 12 all over 3m. And then we have to simplify the numerator. 9 plus negative 12 is negative 3. So we have negative 3 over 3m. Now, you might think that we can just leave this answer as it is, but we actually can simplify it. Because negative 3 over 3 are factors, negative 3 is a factor and 3 is a factor of the denominator, and we can simplify common factors. So, if I divide negative 3 by 3, I get negative 1, and if I divide 3 by 3, I get 1. Our final answer, therefore, is negative 1 over m. Let's try another one. Again, we have common denominator of k plus 2. Therefore, we're going to leave that denominator of k plus 2, and we're going to add or subtract the numerators. Be careful, this one is a subtraction problem. So we have 7k minus 6k. If we simplify the numerator, 7k minus 6k is 1k, or you could have just put k. And in the denominator, we have k plus 2. Is there anything else we can do to this fraction to simplify it? I hope your answer is no, because you can't. Again, we cannot cancel this k with this k, because this k is a term of a binomial. We can only cancel factors. Okay, let's try a couple more examples here. In our first one, we have a fraction with a denominator of 2 plus a fraction with a denominator of 2. Therefore, we can leave our denominator of 2 and add the numerators because we have a common denominator. So 3d minus 2 plus d plus 4. Okay, we're going to simplify the numerator. We have 3 d's right here, 3 times d here, and we have plus 1d here. Together that makes 4d. And then we've got minus 2 or negative 2 and positive 4, and they add up to plus 2. Now you might think you're done, but here's another step we're going to take. If we can now use our simplifying rational expressions rules, we can simplify this further. Remember, in all the examples we've done, we have started with a problem that looks like this, and we've simplified it by factoring either the numerators or the denominators where they're able to be factored. Notice we can factor out a 2 in this numerator. If I factor out a 2, I'm left with 2d plus 2 divided by 2 is 1. I've factored out a 2. Well, now what can we do? Well, we can cancel out a common factor of 2 and 2. Our final answer for this problem is 2d plus 1. Okay, now you might have seen that I changed this problem. We have x squared over 5 times x minus 5 minus 25 over 5x times x minus 5. All right, so notice that we do have a common denominator, so right away we can write that common denominator down. Okay, and now I'd like you to also notice that we have subtraction right here. All right, when there's just a monomial right here, subtracting isn't tricky. In the next example, I'm going to show you how this binomial makes things a little bit messy. So pay attention to the fact it's subtraction. It's just one term right here. So we're going to go ahead and write x squared minus 25. So x squared minus 25. All right, so again, if we are adding or subtracting and we get to a rational expression, we can go ahead and use the skills we've learned in previous lessons to simplify if possible. This x squared minus 25 right here can be factored, as we've been practicing a lot in class. It is a difference of squares, so I can write an x here and here, and then 5 times 5 is 25, so we have 5 here and here, and we make 1 plus and 1 minus, which means I can cancel out, or not cancel out, but kind of cross this out and say I'm done, I use that. Okay? Well, now we can simplify. We have an x minus 5 factor and an x minus 5 factor. We can cancel those out, and then we can write that our answer is x plus 5 over 5x. Remember, x and 5 here are terms that are being added. We cannot cancel either of the terms unless we can cancel the whole thing as a factor. We can't cancel these x's, we can't cancel these 5's. This is the answer. All right, so one last problem. And again, we have to be careful with this one. We have a common denominator of x plus 4, so that's great. But what we have here is subtracting a binomial. We have two terms right here, which means we need to make sure this subtraction sign is shared with both terms in that binomial. All right, so when we go through this problem and write our numerator now, we have to pay attention to that situation. So we have the a from the first fraction, and then we have to do minus 8, and then minus a. And if we miss that, we're going to have some problems. All right, so now we simplify the numerator if possible. We do have like terms that we can combine. We have an a and a negative a. What's a plus negative a? Well, they cancel each other out. So really, all we have left in the numerator is negative 8, and in the denominator we have a plus 4. Again, this is our final answer for this question because we cannot cancel this 8 with this 4, because this 4 is a term of a binomial. All right, obviously, practice will be done in class on this topic. Let me know if you have questions then.